Saxon Math, Course 2, we are on Lesson 24 today, page 169 of your textbooks, and today we're going to be looking at the idea of reducing fractions. Again, this is actually a second part to a lesson that we did earlier in our text, but regardless, we're going to add to some things that we already know. So in the first example, they give us a huge fraction, 420 over 1050. And then the example says use prime factorization to reduce this fraction. So if you remember prime factorization, I'm going to write both these numbers over here and we're going to factor them. Okay. So if we divide 420 by 2, we get 210. If we divide that by 2, we get 105. If we divide that by 5, we get 21. If we divide that by 3, we get 7. So what I'm going to do is I'm going to take these numbers right here and I'm going to put them in order, okay? Meaning ascending order. So 2 times 2, okay? Take those out. And then I'm going to use times 3. That's done. And then times 5 and times 7. Okay? Now, we do the same thing on this side. So 1050, we can see that we can divide that by 5. So let's do that, okay? So we divide by 5 and we get 210. We divide that by let's do let's do by 2, and we get 15. Divide by 3 and we get 5. All right, so let's put this in order. 2 times 3 times 5 times 5. Seems like I'm missing something. One, 5. Seems like I'm missing something. I'm missing a 7. Let me redo this. 1050. If I divide that by 2, that goes in 5. Oops, I want to do this by 5. So I've got 2 here. That's 10. 5, that's 1. 5 minus 0. 210. That's correct. So if I divide that by 2, it's 105. Right, here's my mistake. 105. And then if we do that by 2, then we have 21. And then we do that by 3 and we get 7. That's my mistake. So we're missing a 7. Okay, 2 times 3 times 5. 2 times 1, 2, and a 2. Okay. There we go. Sorry about that. All right, we've prime factored it. So we've got 5, 2, 3, and 7. Man, doing terrible today. Okay, 2 times 3 times 5 times 5 times 7 is the factorization for 1050. Okay, with that said, here's what we can do. We can start canceling out these 2's. We can cancel out these 3's. We can cancel out these 5's and these 7's. And what's left over is literally our fraction. So 2 over 5 is literally what we're left with. Okay? All right, well, that's good. Now, one other thing that I want to demonstrate. Okay, so let's rewrite this, okay, 420 was 2 times 2 times 3 times 5 times 7. And the 1050 was 2 times 3 times 5 times 5 times 7. Okay, so here's what I'd like to do. I'd like to circle each of these that were common factors. And then I want to know what the GCM, or GCF, excuse me, greatest common factor. In other words, what was the biggest number that both of them had? And in this case, it is 7. All right? Or the greatest common factor that they both had, you can see here, both of them had 210 as their largest number there. Okay? So we can find out what that number is pretty easily by just doing those example problems. Okay, all right. Let's go to another example. Let's skip to example 3, where we have 9 over 16 times 2 over 3. All right. If you remember, back when we're reducing fractions, we can actually reduce opposites. So how many times does 3 go into 9? Well, if we reduce this to 1, then this can reduce to 3, and it's the same thing because 3 over 9 is equal to 1/3. If we reduce it, we can divide both by 3, and we can get 1 and 3. The same is true here. If we cancel this out and say this is 1, this will become 8. So we have 3 times 1, which is 3, 8 times 1, which is 8. We can come up with a reduced fraction pretty easily. Okay, so it's all about just reducing fractions. All right, now, one more thing. If we have 27 over 32 times 20 over 63. What we're really saying is if we use our factoring, okay, if we do 27, if we divide that by 3, we get 9. We divide that by 3 and 3. So really what we're saying is 3 times 3 times 3 over 32. Well, what do we do for 32? 32 divided by 2 is 16. We divide by 2 is 8. Divide by 2 is 4. Divide by 2 is 2. So we have 2, 2, 2, 2, 2, 5 2s. 1, 2, 3, 4, 5. And that is multiplied by 20. Well, let's factor 20. Divide by 2, it's 10. Divide by 2, it's 5, right? So 2 times 2 times 5, 63. What do we do there? Well, if we divide it by 3, we'll get 10. 20. Divide by 2 is 10. Divide by 2 is 5. So we're going to do that in order and say 2 times 2 times 3 times 5. Okay, so with this, okay, let's go across. All right, we're still looking at across here, and we're just simply trying to make this easier on ourselves as far as instead of multiplying 27 times 20 and actually doing all the work out and 32 times 63, we can simply eliminate those 2 2's, those 2 2's, and these 5's. So we're left with just 4 on the bottom because 2 times 2 is 4. So let's do that. All right, now let's do the 3's over here. This 3, this 3. No 2's up on top. No 5's. So we're left with 3 times 3, which is 9. And then 2 times 2, which is 4 times. And then here we have 2 times 2 times 5, which is 20, right? So what's the situation with this? Well, 4 times 5 is 20, so 20 times 4 is 80, correct? So we can come up with an answer pretty easily like that. So all we're doing is crossing out and multiplying each of those and making it so that they talk. They're easier to come up with answers. All right, so you can use that method as well when you're doing that. Okay. All right. If you have any questions, let me know. I'll be more than happy to answer them.